Decentralized storage is not a new problem, and long before the ideas of the decentralized blockchain or Web3 were conceived, people were hard at work trying to decentralize the web. In addition to the obvious issues like user experience, user friendliness, and speed, there are some significant hurdles decentralized storage solutions need to overcome before they can become the standard. Here are some of them. Number one, how do we get people to store other people's files? In the traditional peer-to-peer file sharing model, where people were sharing files other people wanted, like music and movies, getting other people to store your files was not difficult because the incentive was to have access to the files. In a truly decentralized storage environment, though, that incentive doesn't exist, or at least it's negligible. Who would want to store CSS files for some random website, or a document, or an FAQ page, or some images for a random product? To get people to share their space on a decentralized storage network, a new incentive must be introduced. The current best answer, introduced by IPFS, is a new storage-based cryptocurrency called Filecoin. Make space available for IPFS to store files, and you earn Filecoin. Need other people to store your files? Pay for that storage with Filecoin. Make Filecoin a blockchain-based cryptocurrency, and storage becomes a tradable commodity people will use as investments. Turn free storage on your computer or server into a moneymaker. Which brings us to issue number 2, equity. For decentralized storage and cryptocurrencies like Filecoin to succeed, large numbers of users must buy into the system by sharing their available storage space and internet connections. But this assumes most users have available data space to share and access to cheap, reliable broadband internet. This is often not the case in large parts of the world and puts people without storage space and internet connections at a significant disadvantage. Some users try to get around this problem by placing their IPFS nodes on centralized servers and cloud hosts, but this counteracts the intentions of decentralization, which is to take power away from those same services. So for decentralized storage and Web3 to succeed, we as a society first need to address global inequity. Even if we solve this equity problem, there's an even more sticky problem to be solved. Number 3, data permanence. The old, as in current web, is built on the premise of data mutability. Nothing on the web is permanent. You can create a domain name and change where it points to. You can set up a server and change its IP address. You can upload a file and then modify or delete it later. This flexibility is what allows us to rapidly evolve the web and the sites and applications that run on it. This mutability is great for content publishing, design and development iteration, and privacy. Things can be deleted off the web, but in a centralized storage environment, centralized powers, including service providers, law enforcement, and governments, can control what content is available and even censor or delete content. In a decentralized storage situation powered by the blockchain, data immutability, data permanence, is implied and often essential. If a blockchain domain points at a resource and that resource is modified, the system breaks. A real-world example of this is when an art NFT is sold and the image the NFT points to is deleted. For the NFT to retain its value, the storage of the artifacts that it points to must be permanent and immutable. Additionally, immutability is necessary to ensure files in a decentralized network are not tampered with. Those of us who lived through the days of peer-to-peer file sharing will remember viruses being distributed as MP3s. To avoid this problem, once a file is uploaded to a decentralized storage system like IPFS, it cannot be changed. If the file needs to be updated, a new set of IPFS objects are added to the system, and those new objects contain the addresses to the old versions. This gives us not only data permanence, but data history permanence. If you're concerned about losing data or data being censored or blocked, this is great. If you need the ability to remove data for any reason, or someone uploads data that is somehow harmful, like personal information, abuse content, criminal content, this is all very bad. Additionally, laws like Right to be Forgotten, GDPR in the EU, and the California Consumer Privacy Act, or CCPA, explicitly give anyone the legal right to demand that their data is removed. This is very difficult to achieve in a system built for data permanence, where a single node refusing to delete data means that data persists indefinitely. As a result, decentralized storage is not only a technical problem, it's an ethical, ideological, legal, and political problem, and all of these issues need to be addressed for Web3 to meet its own promises.